Hello, we are from Group 15. So the title for our open-ended project is Liquid Level Control System in Phenol Production Process. For the introduction part, I'll talk about the phenol production from cumin. Phenol is an aromatic compound with an OH group bonded to the phenyl ring, also known as carbolic acid, that produced from cumin peroxidation process, where the raw material in this process is cumin and oxygen. Furthermore, in this peroxidation process, cumin is oxidizing first with presence of oxygen into cumin peroxide, and then it's decomposed to form phenol and acetone with the presence of sulfuric acid as catalyst to catalyze the reaction. For the problem statement, the emission of sulfuric acid to the air from the separator as a waste produce uplifted concentration in the atmosphere, which this can cause harm to the environment as well as human beings. Objective of this open-ended project has three. First is to create the control system for the sulfuric acid that emit from the separator to the environment. Next is to discuss the challenging concern for implementation of the control system chosen. And lastly, to determine the recommendations for the control system to work efficiently.
Assalamualaikum and hi. So moving on to the next part, which is the control system. So based on the diagram above, our group have selected split range level controller to the system which monitor the liquid level in the separator and control two control valve which connected to the separator, namely as stream 6 and stream 7. For your information, in stream 6 there are mixture of components such as unreacted cumin, acetone, phenol and sulfuric acid. Meanwhile, in the stream 7, which is the bottom product, is a heavy component which is considered as sulfuric acid, will be recycled back to the R102 as a liquid phase. So by assuming the height of the separator, which is the 7 meter, the set point of the liquid level is half of it, which is 3.5 meter. The process variable PV will be the liquid level inside the vessel. So after the level sensor detected the liquid level, the control output signal will be transmitted to the control valve 1 and control valve 2, and OP also will be the opening of the valve based on the configurations such as fail open or fail close. And since this is a split range level control, there are two kinds of situation will occur. Number one, if the liquid level is above the optimum level, which is 3.5, the recycling valve will be open. And the second situation are if the liquid level are below the optimum level, the valve number one will be open based on the control signal being sent by the transducer and sensor. These two situations are referred as split range control, as in which the same controller are used to control two different components. Thank you very much.
Hi, my name is Chengmen. Next, I will talk about the challenging concern in implementing the control system in our process. The main issue with a split range controller is oscillation, as it struggles in maintaining controller variable, which is the liquid level in the separator, based on two manipulated variables, which is the flow rate. So the set point of our process will be the liquid level at 50% of the height of the separator. The process variable will be liquid level in the separator, which will be detected by the level sensor. OP1 will be the inlet flow from valve 1, OP2 will be the outlet recycle stream from valve 2. Usually, a split range control valve configuration will have a small gap between activation of valve actuation. For instance, when the control output signal is below 49%, which indicates a low liquid level in the separator, the control valve 2 may decrease its opening to allow accumulation. When the control output signal is about 51%, which indicates a high liquid level in the separator, the control valve 2 may open wider to increase the bottom flow stream recycle back to the cleavage unit, while valve 1 with a smaller opening. From the setting above, we can see that there is a gap between the activation of valve 1 and valve 2, which are 49% and 51% respectively. In a setup like this, oscillation back and forth across the gap is frequent with any type of gap controller. The oscillation in split range control may be compounded by the fact that many valves do not open or close smoothly while actuating and might cause further error in the system with fluctuating process variable, and the error will be even greater. So the level error will be maintained and unresolved.
Good day, doctor. My name is Mahesh, and today I will be explaining the recommendations to face the challenges stated in the previous slide. Now the challenges are the reason why we can't reach our desired set point value. Now the main challenge was oscillation in split range control system. Now this can be avoided by tuning the controllers in a manner where there should be an overlap between the valves. Now for example, when valve 1 is 100% open, valve 2 would be 100% closed. And the graph goes in this manner as shown down here. They both overlap at the 50% mark. What I mean is when valve 1 is 50% open, valve 2 is also 50% open. And now as valve 2 gets 100% open, valve 1 is only 0% or fully closed now. Next, a sensitive actuator should be used while the valve should be designed with a smart positioner. A smart positioner is something which helps and improves the response time of these valves. And lastly, we should remove the integrated controller action around the changeover point. This function will create a tiny offset, but oscillation will be considerably reduced. Thank you very much.
Okay, my name is Muhammad Madani, and today I will explain about the conclusion of this project. Towards the end of the project, we know that the production of the phenol from the cumin has many undesired products which are harmful and dangerous to the environment. And one of the undesired product is the sulfuric acid. In order to reduce the emission of the sulfuric acid to the environment, a control system which is liquid level control system is introduced. This control system could maintain a consistent level along the process to ensure the stable and continuous sulfuric acid flow and to avoid ineffective separation, which is increase the cost on further purifying the product. So in this case, the emission of the sulfuric acid could be controlled and prevent the environment from being polluted. Thank you and good day.